Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
After 5 long months of eerie silence, Voyager 1 suddenly started talking again. Launched way back in the 70s, this old space probe is now millions of miles away, far beyond our solar system. It can't send back any science stuff right now, but it's still managing to send updates about how it's doing out there in the vast cold darkness. What's Voyager 1 trying to tell us from the fringes of space? And why now, after all this silence? Let's hear the chilling message Voyager 1 broadcasted after 5 months of no contact. Voyager 1's health check from the stars. NASA's Voyager 1 spacecraft, a space explorer traveling beyond our solar system, has started communicating clearly with its control team on Earth once again. On Saturday, April 20th, the team received an update from Voyager 1 about its condition, marking the first such communication in 5 months. Although Voyager 1 isn't currently able to send back scientific data, it is successfully sending back important information about its own health and how well its systems are working. Voyager 1 was launched way back in 1977, and after 35 years of traveling through space, it became the first object made by humans to exit our solar system and venture into the space between the stars, known as interstellar space. This milestone was a huge achievement, showing just how far human ingenuity can reach. 6 years after Voyager 1, its sister spacecraft, Voyager 2, also left the solar system in 2018. Fortunately, Voyager 2 is still up and running and maintains good communication with Earth. The trip of Voyager 1 is an incredible story of human achievement. It was built and launched by NASA, the United States Space Agency, with the goal of exploring the farthest reaches of our solar system and beyond. This spacecraft has traveled farther than any other human-made object, making it a pioneer in space exploration. Its mission has helped scientists learn much more about the outer planets and the edges of our solar system. Now, as it travels through interstellar space, Voyager 1 continues to send back data that scientists use to understand more about the universe. The communication system on Voyager 1 plays a critical role in its mission. It uses a powerful antenna to send signals back to Earth, which takes over 20 hours because of the immense distance. Voyager 1 is billions of miles away from us. When NASA didn't hear from Voyager 1 for 5 months, there was concern about whether it was still operational. The recent communication that confirmed the spacecraft's operational status was a relief and an important update for the team monitoring it from Earth. As it moves through space, Voyager 1 carries with it a golden record filled with sounds and images of Earth. This record is meant as a message to any potential life forms in the universe, showcasing the diversity of life and culture on Earth. It is a symbolic gesture representing the hope that there is more to discover in the vast universe. Voyager 1 and another spacecraft are the only 2 human-made objects that have traveled into space far beyond where the sun's influence reaches. But on November 14, 2023, something went wrong. Voyager 1 was 15 billion miles away from Earth when the simple code it uses to talk to NASA suddenly stopped making sense. This code is just a series of zeros and ones, and it's crucial for communication. Back in March, the team handling Voyager 1 at NASA tried to fix the problem. They sent a signal, a digital poke, to the spacecraft. This made Voyager 1 send back a complete report of its memory to Earth. When scientists and engineers looked at this memory report, they discovered the problem was a tiny part of the spacecraft's brain. Just 3% of it had messed up. This tiny part is on a chip, and the damage to it made it impossible for Voyager 1 to send back useful information about the science and engineering it was doing. Since NASA can't go up there to fix or replace the damaged chip, they had to come up with a workaround. They decided to move the messed up code to different parts of Voyager 1's memory. The problem is, there's no single spot in the memory big enough to take all the code at once. So they planned to break the code into smaller pieces and spread these pieces around in different memory sections. To make this work, NASA's team also needs to tweak these memory sections so they can handle the broken code without causing new problems. This means making sure that these sections don't stop working on their own or stop working with each other. On top of all that, NASA engineers need to update all the pointers. These are directions that tell the spacecraft where in its memory to find certain pieces of information, so they lead to the new locations of the code pieces. This complex task shows just how challenging and critical it is to manage spacecraft technology, even from billions of miles away. On April 18, 2024, The NASA team started a very careful and slow task of moving the broken computer code to a new part of Voyager 1's memory. The process was especially challenging because Voyager 1 is so far away from Earth, about 15 billion miles. A single radio message takes 22.5 hours just to travel from Earth to the spacecraft. After sending a message, the team has to wait another 22.5 hours to hear back. This means that every attempt to fix something takes a very long time to even know if it worked. Despite these difficulties, by Saturday, April 20th, the NASA team had some good news. They successfully relocated the code, and for the first time in 5 months, they could talk to Voyager 1 properly. They were able to check how the spacecraft was doing and make sure everything else was working right. This was a big relief because being able to communicate with Voyager 1 means they can continue to get important scientific data from the edge of our solar system. The work isn't over yet, though. Over the following weeks, the team plans to keep fine-tuning the rest of the memory and software inside Voyager 1. They're particularly focused on the parts of the system that handle the scientific data, collecting it, packaging it, and sending it back to Earth. These adjustments are crucial for making sure Voyager 1 can keep sending valuable information from where no other man-made object has flown. The goal is to fix the sections of the spacecraft's memory that were affected by the corrupted code, ensuring that all parts can operate smoothly and efficiently together. This kind of remote repair job is incredibly complex because it involves programming and problem-solving from billions of miles away. Each step needs to be planned meticulously, and there's a lot of waiting involved. Waiting to see if the changes have made a difference, and waiting for new problems that might need more attention. Despite these challenges, the team's ability to adapt and handle issues from such a distance is a testament to their skills and the advanced technology we have today for space exploration. Their ongoing efforts help us understand more about the outer reaches of space, continuing to add valuable knowledge to our understanding of the universe. Let's explore the advanced tech that lets these spacecraft communicate from billions of miles away. Voyager's long trip with a nuclear heart. These spacecraft have traveled more than 12 billion miles from our planet, continuously sending back valuable data that has consistently amazed and thrilled those studying outer space. This information has often brought to light new discoveries that have reshaped our understanding of the universe. Recently, NASA highlighted one such finding, a discovery so important that we'll be delving into it in greater depth very soon. The uniqueness of the Voyagers isn't only due to the vast distances they cover or the new knowledge they uncover. A key feature that sets them apart is their source of power, radioisotope thermoelectric generators, RTGs. These devices, also known as nuclear batteries, use a process known as the Seebeck effect to convert the heat from decaying plutonium into electricity. What's remarkable about these generators is that they operate flawlessly without any mechanical parts. This lack of moving components greatly lowers their risk of malfunctions and makes them perfectly suited for the harsh environments of deep space. Unlike solar-powered devices, radioisotope thermoelectric generators don't need sunlight to function. This independence from solar energy is crucial for missions venturing into the less illuminated regions of our solar system and beyond, where sunlight is scarce. These radioisotope thermoelectric generators have been instrumental in keeping the Voyager spacecraft operational as they trip through the harsh void of space. Their reliability and longevity allow the Voyagers to continue their mission, exploring areas of space that were once considered unreachable. Thanks to these power sources, the Voyager's data has provided scientists with insights into the conditions and phenomena occurring in the farthest reaches of our solar system, offering a clearer picture of what lies beyond the familiar confines of our celestial neighborhood. The power systems of the Voyager spacecraft, though highly effective, do have their drawbacks. The main issue is that the plutonium which fuels the radioisotope thermoelectric generators gradually decays over time. As it decays, the amount of power these generators can produce slowly drops. However, the mission has still been a success due to the smart strategies implemented by NASA's engineers. They've managed to prolong the operational life of the Voyagers by shutting down heaters and other systems that aren't essential for the basic functioning of the spacecraft. This careful conservation of energy ensures that the Voyagers can keep traveling through space even with decreasing power supplies. The clever design of the Voyager probes extends beyond just managing their power. They are equipped with a special 8-track tape system designed to store and manage the data they collect. This system works in a fascinating way. Various scientific instruments on board the spacecraft continuously gather different types of data, such as images, sound recordings, and scientific measurements. This data is then converted into a digital format and recorded onto magnetic tapes. Each tape features 8 parallel tracks, maximizing the amount of information that can be stored. When it's necessary to send data back to Earth, the spacecraft's computer system selects the relevant data from these tapes. It then transmits this information across vast distances of space, using the spacecraft's powerful high-gain antenna to ensure it reaches NASA scientists on Earth. This data management system is crucial because it allows continuous, long-term data collection and storage under the harsh conditions of space. The 8-track tapes are specifically designed to withstand the extreme environments of space, such as intense radiation and cold, which are challenges that ordinary storage devices might not survive. Furthermore, the efficiency of this tape system means that even as the power availability decreases, the Voyager can still gather and send back valuable scientific information. The ability of this system to operate effectively, despite limited power, showcases the forward-thinking engineering that has gone into Voyager's design. The information sent back by these tapes provides scientists with insights into the far reaches of our solar system and beyond, continuously contributing to our understanding of the universe. Back on our planet, special stations receive the signals sent by Voyager and turn them into data that scientists can study. The tapes that store this data are made tough to survive the brutal conditions of space. They have a metal base, often made of stainless steel, which resists radiation, and are coated with a magnetic layer that keeps the digital data safe despite the extreme cold, heat, and emptiness of space. Additionally, these tapes are encased in special housings that protect them from space debris, like tiny meteoroids, ensuring they keep working far into the future. Even though they use old technology, these tapes are incredibly reliable. Day after day, they continue to work, constantly sending valuable information back to Earth. This reliability proves how well they were made, designed to keep functioning over decades in the harsh environment of space. The contributions of the Voyager probes go much deeper than these technological feats. At the start of their missions, the Voyagers sent back pioneering information about the moons of Jupiter and Saturn. More than 40 years ago, this data showed that these moons were not just simple, inactive rocky bodies like our moon. Instead, they were found to be complex worlds buzzing with geological activity. For instance, Voyager 2 made history in 1986 as the first spacecraft to pass by Uranus, revealing new secrets of our solar system and adding another layer to our understanding of the unknown. Just 3 years after its encounter with Uranus, Voyager 2 made a close approach to Neptune, accomplishing a feat that remains unmatched to this day. As these spacecraft press on in their impressive paths through space, NASA has taken steps to keep them running longer. In the last 3 years alone, they've shut off heaters and other parts that aren't essential, helping the Voyagers save energy and continue their missions, possibly until 2030. This extended lifespan allows the spacecraft to continue providing valuable data that reshapes our understanding of space. For the team of scientists and engineers who have nurtured the Voyager missions from the start, watching these spacecraft achieve and surpass their goals is both joyous and slightly melancholy. Their relentless effort and commitment have propelled the project beyond what anyone first imagined. The discoveries made by the Voyagers have revolutionized our knowledge, sparked numerous scientific breakthroughs, and motivated waves of new researchers fascinated by the secrets of space. These achievements inspire us to keep exploring and questioning our place in the cosmos, driven by the legacy of these distant travelers. Next, discover the sights and discoveries Voyager made among distant planets and moons. Voyager's perfect shots from the cosmos. Voyager 1 and Voyager 2 were no ordinary spacecraft. They were carefully engineered to be extremely stable, spinning very slowly, over 15 times slower than the hour hand on a clock. This slow rotation helped ensure that the pictures they took were clear and sharp, without any blurring, even as they sped through the vastness of space. The ability of these spacecraft to take such clear images surprised both scientists and the general public long before the spacecraft reached the farther planets in our solar system. As they approached Jupiter, still several months out, the Voyagers began sending back pictures, These images showcase Jupiter's swirling clouds and its famous Great Red Spot, thrilling those who saw them at NASA's Jet Propulsion Laboratory. But the real excitement came with the discovery of active volcanoes on Jupiter's moon Io. This discovery was particularly startling because Io, only slightly bigger than our own moon, was found to be the most volcanically active object in our solar system. The instruments aboard the Voyagers picked up strange signals coming from Io, which were later confirmed when the spacecraft sent back images of massive volcanic plumes and landscapes reshaped by volcanic eruptions. These breathtaking images showed volcanoes on Io spewing jets of gas and volcanic debris high into space. One of Io's largest volcanoes, named Pele, erupted with such force that it sent material 30 times higher than Mount Everest into space, covering a region almost as large as France. This extraordinary activity on Io was a pivotal moment in the Voyager missions, offering profound insights into geological processes on other worlds. The findings from Voyager's exploration of Io challenged previous notions about the Moon and provided critical data about volcanic activity in space. It highlighted how much there is to learn about the dynamics of other celestial bodies. Additionally, the Voyager's trips have continually demonstrated the incredible capabilities of human-made technology to withstand and operate in the extreme conditions of space. These missions have expanded our understanding of the solar system's boundaries and the possibilities for life and geological activity beyond Earth. The Voyager spacecraft has taken more than 33,000 stunning photographs of Jupiter and its moons, capturing the immense beauty and varied landscapes of the moons orbiting this giant planet. Before they started sending the worrying signals we now analyze, these twin spacecraft had already changed our view of the solar system with their incredible findings. Among the most unexpected discoveries were the rings of Jupiter. Another astonishing revelation came from Voyager 2 when it showed that Europa, one of Jupiter's 53 named moons, has a thick icy crust extending over 60 miles deep. These observations challenged what scientists previously thought about these distant moons and sparked new research into whether these icy worlds could support life. As they flew past Jupiter, the Voyagers used the planet's gravity to slingshot themselves faster into space, gaining the speed needed to escape the sun's pull and travel to further destinations. Shortly after their encounter with Jupiter, Voyager 1 and Voyager 2 split up to explore different parts of the solar system. Voyager 1 made its way towards Saturn's moon Titan, which is enveloped in a thick orange, smog-like atmosphere. The mysterious atmosphere of Titan fascinated scientists, prompting them to delve deeper into studying its intricate chemical properties. After its close encounter with Titan, Voyager 1 changed its course, moving upward out of the plane of the solar system's planets, pushing forward into the unknown stretches of interstellar space. Meanwhile, Voyager 2 continued on a trajectory that took it towards the outer planets, venturing to the very edges of our solar system. Each of these paths taken by the Voyagers not only broadened our understanding of the solar system's farthest reaches, but also provided crucial data that has propelled numerous other missions and scientific inquiries. The impact of the Voyager missions extends beyond simple exploration. By sending back detailed images and data from Jupiter and its moons, and then from Saturn and beyond, the Voyagers have helped us visualize and understand the dynamic processes that govern these distant worlds. They've shown us that our solar system is a place of dynamic change and complex beauty, filled with worlds that might be very different from Earth, yet hold clues to the fundamental processes that also shape our own planet. In 1986, Voyager 2 made a historic pass close to Uranus and discovered 10 previously unknown moons, significantly increasing the known moons orbiting the planet. This event was monumental because it added vast new knowledge about Uranus. Just 3 years after this significant discovery, Voyager 2 reached another milestone by arriving at Neptune, which is known as a distant ice giant in the outer reaches of our solar system. During its close approach to Neptune, the spacecraft recorded staggering wind speeds of up to 1,000 miles per hour, the fastest winds ever detected on any planet in our solar system. This encounter offered scientists a rare glimpse into the extreme weather conditions that can exist on other planets. As Voyager 2 traveled just 2,980 miles above Neptune's beautiful blue atmosphere, which is rich with methane, It sent back valuable information that provided deep insights into this faraway world. Among the many discoveries, Triton, Neptune's largest moon, stood out as one of the coldest known places in our solar system, with temperatures diving down to a chilling -391 degrees Fahrenheit. More intriguingly, Triton displayed some extraordinary geological activity. It has ice volcanoes that spew nitrogen gas and icy particles high into its thin atmosphere, reaching altitudes of 5 miles. These findings not only broadened our knowledge about Neptune and its moon, but also deepened our understanding of the dynamic processes that occur on celestial bodies so far from the Sun. The information Voyager 2 gathered added to our understanding of the diversity and complexity of the planets and moons that reside in the outer solar system. This mission has shown us that these distant regions are not just frozen wastelands, but also dynamic worlds with unique geological and atmospheric phenomena. Dive into Voyager's most iconic images, including the profound pale blue dot. The pale blue dot from billions of miles. Carl Sagan, a highly respected astronomer, played a crucial role in expanding the ambitions of the Voyager missions beyond their original scope. As part of the Voyager mission's imaging team, he was a strong advocate for taking one final set of photographs with the spacecraft's cameras before they were permanently deactivated. Sagan believed these images would serve as a profound farewell gift to humanity, providing us with one last look at Earth from billions of miles away. His dedication and persistence in this endeavor were relentless. Sagan's efforts bore fruit on Valentine's Day in 1990, when Voyager 1 turned its camera back toward the direction of the inner solar system and captured a series of 60 images. Among these, the most memorable is the image known as the pale blue dot. This photograph has become an iconic representation of Earth's minuscule presence in the vast cosmos. Captured from an astonishing distance of 3.8 billion miles, this image shows Earth as nothing more than a tiny, faint blue dot against the vast black backdrop of space, underscoring our planet's fragility and isolation in the universe. This remarkable achievement not only fulfilled Sagan's vision, but also inspired countless individuals around the world to think differently about our place in the universe. It reminded us of our tiny presence in the vast expanse and promoted a sense of shared responsibility for the welfare of our planet. The pale blue dot stands as a testament to human ingenuity and the spirit of exploration that defines our species. But the Voyager missions have uncovered more than just striking visuals. They have also brought to light new insights into the stark emptiness of interstellar space. NASA has found that cosmic rays, high-energy particles traveling at nearly the speed of light, are 3 times more intense beyond the heliopause, the boundary marking the end of the Sun's influence and the beginning of interstellar space, than they are within the confines of our solar system. This discovery has deepened our understanding of the heliosphere and the kinds of conditions that exist in the more remote parts of space. Moreover, combining data from Voyager with information from subsequent missions has revealed mysterious sounds emanating from the depths of interstellar space. Voyager 1 picked up an eerie humming noise that seems to be linked to tiny fluctuating waves within the sparse interstellar gas. While some scientists attribute these sounds to natural space phenomena, others speculate more sensational origins, suggesting they could be signals from extraterrestrial life forms. Although this theory is far from universally accepted, it continues to intrigue and provoke lively debate among scientists and the public alike. For over 45 years, the Voyager missions have been on a trip to uncover the secrets of our solar system. The discoveries they have made have been more startling and mysterious than anyone could have imagined. One of the biggest surprises has been the behavior of the heliopause, the boundary that marks where the Sun's influence ends and the vastness of interstellar space begins. Scientists used to think this boundary was a simple, stable line. The heliopause is actually a complex, constantly shifting barrier that changes shape and position. This discovery has puzzled and sometimes worried researchers who are trying to understand what these changes mean for the future. The Voyager spacecraft have also collected critical information about the Sun and how it affects the space around it. These insights help us understand the Sun's powerful influence over our entire solar system. What's even more remarkable is that the Voyagers are operating in conditions that are much colder than what they were originally designed to handle. This defies our usual expectations of how space technology should work, pushing the boundaries of what we think is possible. As scientists combine the data from the Voyagers with information from other space missions, they are starting to build models to predict how the heliopause might change. But the forces involved are unpredictable and uncontrollable, making it hard to know what lies beyond our solar system's borders. Could there be dangers or hostile forces out there? The answer remains hidden, and only time will reveal what's truly out there. Recent studies on the heliopause have brought back confusing data, leaving the scientific community both baffled and fascinated. Back in 2014, the Interstellar Boundary Explorer, IBEX, detected an increase in the brightness of energetic neutral atoms, ENAs, indicating that the heliopause does not behave as previous models had predicted. This observation suggested asymmetries and irregularities that contradicted what scientists had long thought about this space boundary. Then, adding to the intrigue, Voyager 1 and Voyager 2 sent back data showing that the heliopause had undergone significant changes in a relatively short time. Researchers refer to this intriguing phenomenon as entry speaking, and it has spurred a renewed interest in studying the heliopause more deeply. But perhaps the most shocking update came last May, when Voyager 1's attitude articulation and control system started sending back garbled data that made no sense. It was as if the spacecraft had suddenly lost its ability to speak clearly. This situation, somewhat akin to the human condition of aphasia where people struggle with speech, was unexpected and left engineers scratching their heads. Gear up for NASA's next big project, the Interstellar Mapping and Acceleration Probe, poised to uncover deeper cosmic secrets, probing the edges of solar influence. In 2025, NASA plans to launch the Interstellar Mapping and Acceleration Probe, aiming to delve deeper into the secrets of the heliopause and the far edges of our solar system. This ambitious project seeks to enhance our understanding of the boundary where the sun's influence ends and the secrets of interstellar space begin. Are you prepared for a thrilling experience? In 2019, a decade after it began its trip into the unknown reaches of space, something unsettling happened to the spacecraft. Although it continued to send strong radio signals back to Earth, indicating that it was still operational, the messages it transmitted were unusual and perplexing. A jumble of confusing data replaced the normal updates about the spacecraft's health and status. What could be causing such bizarre behavior? NASA engineers investigated and discovered that the attitude articulation and control system, which helps the spacecraft orient itself and maintain its course, was not functioning properly. It was sending back garbled information, leading to a lot of head-scratching among the team back on Earth. Initially, it seemed like the computer system managing the AACS might be malfunctioning, corrupting all the data being sent from the spacecraft. This unresolved issue continues to haunt the engineers and scientists involved as they ponder what could have gone wrong in the depths of space. This incident adds another layer of intrigue to our ongoing exploration of space. As the IMAP mission approaches, scientists are eager to use the new tools and instruments it will carry to investigate not just the heliopause, but other unusual phenomena occurring in the outer solar system. They hope to gain clearer insights into why such anomalies occur and what they might mean for our understanding of the universe. With the launch of IMAP, we are on the brink of potentially groundbreaking discoveries that could answer some of the long-standing questions about our cosmic neighborhood and beyond. However, the strange events surrounding the older spacecraft remind us of the challenges and unpredictabilities of space exploration. As we push further into the cosmos, each mission builds on the past experiences, using new technology to solve old secrets and undoubtedly uncovering new ones along the way. Try to picture the eerie feeling of being alone in the endless dark of space while your equipment starts to fail in ways that no one can explain. What other secrets and dangers might lie out there beyond the reach of the sun's magnetic field? It's hard to predict, but let's explore the design of the spacecraft to understand what the engineers were thinking. NASA's engineers planned for the possibility that the Voyager spacecraft might encounter extraterrestrial life as they mapped its trip into the unknown regions of interstellar space. This brave leap into the cosmic unknown was undertaken with the idea that meeting alien life was a real possibility. As Voyager 1 and Voyager 2 moved beyond the comforting shield of our heliosphere, they carried with them a powerful message from Earth in the form of the Golden Record. This was no simple message. It was a deliberate invitation to any intelligent beings that might find it as they traveled through space. The golden record serves as a time capsule, capturing the essence of humanity. It includes a stunning array of Earth sounds and visuals, from the classical melodies of Beethoven to the serene notes of Guanping Hu's flowing streams, along with friendly greetings in 55 different languages and the natural sounds of our planet like thunder, birdsong, and laughter. It also includes diagrams showing how to play the record in case beings from another world find it. Is Voyager 1's message a warning from deep space or just a glitch? What do you think is really happening? Hit like, subscribe, and share your thoughts below for more.